Good evening and welcome to tonight's webinar on dynamic math visuals using ClassPad.net to create dynamic visual representations with variable sliders and functions. For the sake of webinar quality, we are going to keep everyone muted and all videos turned off. If you do have a question, please type it in the chat panel and one of our moderators will respond back or ask the presenter to respond to the group. My name is Amy Chow, and I am moderating tonight. I am Casio's National Training and Product Manager, and tonight we have Dr. Karen Greenhouse presenting for us. Karen, I will actually just pass it over to you and let you introduce yourself now.
Okay. Well, hi, I'm Karen Greenhouse. I recognize some of you, so welcome back. And just real brief, I am Casio's spokesperson and a consultant. It's going on my 6th year. I'm a teacher. I teach at Drexel right now, and I have been in love with technology and math teaching forever since I found Sketchpad. So that's sort of what we're doing today is how do you use technology to make math dynamic. So one thing I am going to ask is that you play along, because I really am doing kind of more of a how-to, how to create sliders, how to make dynamic visuals. So it'd be a lot more fun for you if you're actually playing along. So if you don't have a Sketchpad account, I'm going to talk about, not Sketchpad, ClassPad account.
Wait, what?
I know, sorry, that was a slip of the tongue there. I do want to send out a quick poll just so I sort of know how much overview I should do. So if you could just respond real quick to your kind of comfort level with ClassPad, it gives me just a basis of how much in depth I need to go, or if I can just kind of skip over things. So just real quick, if you could just answer that. All right, so it looks like so far we have people that have at least definitely exposure to it. So that is awesome. All right, I'm going to stop. Here's my results if you want to look at them. All right, so what I'm going to do, if you have an account, hopefully you have it open and you can play along. You just need to be on a blank screen. If you don't have an account, I am going to show you what you can do. You don't have to go and create an account right now. You can just work on, and Amy, let me know if this shows up. I'll move my picture. Can you see my screen? All right.
Yep.
So if you have an account, hopefully you're logged in. If not, you can just go to ClassPad.net. So this is the landing page for ClassPad.net. You do not have to create an account to play along. You can just hit this Start Exploring button with, and start doing everything with us. So don't worry about having an account or trying to create one right now while we're working. You can just start exploring and later go back to create accounts. Anything you do that you are wanting to save, you'd want to create the account before you close out of it. Real quick, for those of you not familiar to the site has a lot of resources on it. You can look at our previous webinars. You can go to all the how-to videos that we have. There's free activities, ready-to-use lessons by subject and sticky. So lots of resources here. You can scroll down and see those same things. What I would like everyone to do is if you have your account, open it. If you don't, just hit the Start Exploring button and trying to think if I want to log in. Well, let's just do it through Start Exploring right first off, and I'll log in a little bit. So Start Exploring takes you to the blank page. If you have an account, I want you to have an open blank page. I'm going to click, it says create a sticky note. I'm just going to click somewhere. Those of you new, these are all the things you can do with ClassPad. You can do calculate, you can do graphing, geometry, statistics, sequences. When you have an account, you can do financial templates and then text. We're going to be working with how to use variables and dynamic sliders to really make students see and understand what's happening to the mathematics content. And so for that, most of the time today, we're going to be in the graphing functionality and in the geometry, because these are the main two where you can use sliders, create sliders to help you visualize. And there's a brief one in statistics, and if I have time, I will show you that, but I really want to kind of focus on these two. So if everyone can hit graph and open just a graph space, so this is a sticky, move it wherever it makes sense to you. And I'm going to graph, now I have a specific function that I'm going to graph, but you can graph whatever you want, but I'm starting with a linear in slope-intercept form. So I want to graph that function, so I'm going to hit the down here at the bottom, my function, y equals. And so I'm going to type it in as y equals. You could do f of x if you want, but I'm just using y equals, and I'm doing -3x plus too. Now I'm using my my keyboard on my computer, but you can also use the soft keyboard. So once you enter your function, oops, that is not the one I wanted. Oh, no, yeah, it is. Okay, here's my function, right? And so if I just enter a function with specific numbers, students can explore and they can click on the function, right? And see, you know, how does this point, this key point, what does this represent? How does it have anything to do with this equation? So they can explore things like by just looking at the graph. But if you can use sliders where you can modify and change things dynamically, then they can start really kind of understanding, what do these coefficients mean? What does this constant mean? What does this coefficient with the x actually mean? So, and I did want to point out, I'm in not my account. If you're in your account, you might have your numbers showing up as in standard form. So this 0.67 is probably a fraction. When you're not in an account and you're just in as a guest, you don't have the option to see the standard form. So creating an account lets you see the standard form. So let me just show you the difference. I'm going to actually log in to my account. Or maybe not. Yeah, I'm not going to waste time doing that. I'll go back to that. So what I want to do is, okay, so we've got this point. I want to now, instead of using numbers, do the same linear point slope form, but this time I'm going to use variables. So you could use whatever variables you want, except for obviously x and y, because they already have their own purpose. So what do we normally teach students? We use the variable m to represent slope. I don't really ever understand why we use m. I think it should be s. And then we use b to represent the intercept. So I'm going to use those. And one thing I want to point out, when you're creating sliders and you have multiplication division right here with the x variable or the y variable, you want to actually put in the multiplication, which I'll show you why in a minute. If I don't, if I just do mx plus, and let's use b. So I've replaced these with variables. Because I do not have a multiplication symbol here between this variable m and the variable x, ClassPad uses multi-character variables. And so what happens, and I'll just show you real quick, when I hit enter, it creates sliders. So the minute you put in variables to represent numbers, it creates a slider for each variable. So watch what happened down here. It interpreted that as a multi-character variable, not as m times x. And notice that it just graphed a straight line. And the reason is this is really just a constant if you put these together. So I need to go back up into this and make sure I put in the multiplication symbol. And now you'll see the difference when I hit execute. So now it's just the variable m and it's just the variable b. But now the difference is, because these are sliders now, they are controlled. The movement of this line is controlled by these sliders right here. And I can now move them. And maybe the first thing I do is, okay, can you make these sliders match this original function and what happened and how is the movement happening? So before I do that, I want to talk about the range. So the sliders will come up with a range. Default's always -10 or 10, unless you're in geometry and you're working with rotations, then it's going to be angles, so up to 360. But this is usually the default. So you might want to look at your window, and you know, I don't necessarily want a B that's past the window, or I could change my window, but I might say, okay, well, I can only see maybe up to 7. So let's just change it. So changing them is very easy. You can change them to whatever numbers make sense to the window that you're looking at. And well, I think I'm going to leave my slope that way. And then up here is step. So the default is that it starts stepping by tenths, which is a very slow step. So maybe I don't want, maybe I'm working with students just learning about this, and so maybe I only want whole numbers. So I might put in step by 1. So it's going to go -7, -6. So let's just put, yeah, we'll just do that for now. So once you kind of decide what's your range that you want, what's your step, how do you want it to move, then you can start exploring by moving it by hand. So notice when I click on the sliders, it gets this blue box around it. That means I've selected the slider sticky, and now I can move the point on one of the sliders. So I'm going to move it manually, and this is still something they are working on, but it doesn't You don't see it move till after you've, well, it moves a little slower than it should, but watch what happens as I'm moving this. My line is moving, and maybe we want the students to click on key points and, you know, see if there's a connection, right? So as I move this slider, is there anything that's actually matching the B? Whoops. And I can click again. So then maybe they're making that connection. Oh, this is somewhere on this y-axis. So you can have them looking at that. And it's the same thing here. I can turn my slope. What's moving my slope? What's happening when I move my slope? It's changing the slant direction of my line. And when it's negative, I'm going down. When it's positive, I'm kind of going up to the right. So these are the kind of things they can notice because you now have a slider and they can see the change happening as you're moving. These little buttons right here, the little arrows, will also animate. So if you didn't want to do it manually, you could, you know, make it fast. And it's going pretty fast because my range is really small. So the larger your range, the slower it will go. It's going really fast. I don't have a very big range. So that's one way to do sliders, right? And so what I like now is, okay, so let's say if you explored this MX and plus B, and now you want to give some names to these things, you could go back up and change them to be what we represent. So this is a nice thing about ClassPad is you can do multi-character variables. So when I hit enter here, my M is now a slope. And so now they realize this number that's in front of the X variable is the slope in this form, which we always call slope intercept. Well, why are we calling that? Because this value represents the slope of the line. And when I move it, I can see that the line is changing its slope, tilt, however we are talking about it with our students. And then this line up here, I could do the same thing. Now, I do believe, Amy, I'm not sure, I think it's 8 characters, but let's see how far it lets me. Oh, I'm wrong. Yeah, see, it doesn't like, it's too many. Only.
Yeah, so it is 8 characters.
It's 8.
You have to limit your
So maybe I want to say intercept. Okay, so that's really nice. You can use actual one variable characters, or you can use multi characters to really describe what those sliders are representing. So that's really nice. Another thing you can do, so this was in slope intercept form. Well, what happens if I make another line that is in, say, point slope form? And here I can reuse a slider. So point intercept form is, and let's just do it the way they do, is y minus some point. So we're going to call the second point y2. So notice my variable is now a letter and a number, and that's okay. And then I want to use the same slope that I used down here to show that connection, right? So I'm going to say slope again, and I want to make sure, let's use our parentheses, x minus x2. And so now it's going to graph another line currently parallel because notice it's the same slope as the one before. So this then gets you into some interesting conversations. That's, you know, 2 lines with the same slope are parallel to each other. How could I get them to be exactly the same? What would I have to do? Notice that each one of these is a function, even though we're using the variables, the sliders, so it has table capability. So you could now pull up your table and actually compare, like, where's this point? What's this point y, x2, y2? Where is that point? So you could have them exploring things like that. And then now you can move your point. So can they identify where that point is? And notice I did not change the, so this is the point 1, 4. We can find it on our table. Right here, 1, 4, we can talk about what happened to the line. Where is that point on the line? And we could put a point somewhere and actually try to find the point on the line. So there's lots of things you can do with these variables. So this is just a very simple example using a linear equation, right? So are there any questions before I move on to just another type of equation?
Yeah, we did have a question, Karen. Is there a way to hide some of those equations or hide the equations so that the students don't see like the original equation that we put in blue?
Yes. Okay. So that's a great question, and we were going to get into that, but we'll get into it right now. So one of the nice things is, yes, you can create things ahead of time and hide them. Unfortunately, This is kind of a disadvantage. You can hide them right here. When you click on the color, you have the option to hide the graph and also change the line to solid or dash. So when I hit hide the graph, they won't see that anymore. Unfortunately, and they're still working on this feature, I can't actually hide the equation that they see. So it's a little frustrating. So I'll give you another option that you can do. So let me show you a different option. And I'll show you in the next example that I'm going to show you. So I want to make sure. So one nice thing before I move on, I'm going to create another graph sticky. All of these variables or sliders exist for the rest of the paper unless I change them. So if I use X2 again in the next graph, it's going to move up here as well. So I kind of don't want that to happen. So I'm actually going to just close out my whole thing. When all else fails, close. But I did want to, let's see if I did that. No, okay, good. All right, so I'm going to open another graph sticky. And this time I'm going to show you a way to kind of get around that. You can't actually hide the equation, even though you can hide the graph of the equation. Another way to do it is to use the calculate sticky. So if I get the calculate sticky and I define a function first, so I'm going to define a function in the calculate sticky, and what that does is it allows that function to be used throughout the paper without having to type it again, because the paper or the ClassPad knows that once you define a function, wherever you use that function, it's the same function. So if I use it in 3 different graph stickies, it's the same function no matter how many times I use it. And you can then hide this calculate sticky under a graph or something and they can't see it. So let me explain what I'm talking about. So here's my next example. So I'm going to use f of x, whoops, and to define something basically that you want to use over and over again, that's why we call it a define thing, you're going to use, instead of equals, this little button right here, this little template, which is the define button. So it's a colon equal if you're just typing on your computer. So I'm going to enter, my second one's going to be a parabola. And, oops, I always do that. You got to remember to hit your arrow to get out of the exponential area. I wanted minus x plus 3. All right, so by defining all this, so notice it says done. It didn't do anything with it. I've simply told ClassPad that this is, every time you see f of x, this is the function I want you to use for it. So now I could hide this under the graph, and it's not available for students to see, but I know it's there, and I know that I want to use it. So now when I'm in the graph, instead of typing that function out as I did, all I have to do is y equals f of x that I defined, and now it puts that function there. So that is a way around things like that you want to hide, define them in calculate, and then you can hide the calculate sticky under the graph. Eventually, we have it for some of our publishers, so I'm hoping it comes at some point. Eventually, there is a feature where you can actually click up here and hide the function. And so even though you on the original see it, a student opening the copy you send them won't see it. But that's not here yet. It's coming, but so that's another way that's hopefully down the road. So I wanted to just show you again another nice feature for sliders and how you can actually use the same sliders in different representations. So this is a parabola. And let's say I have them do the standard form of a parabola. So I'm going to do A, and let's remember that's my variable, and I want to make sure I use the multiplication to show that I'm multiplying by x. And so then this is just the standard form of a quadratic. All right, so we're all familiar with that. But now I have sliders that represent this, and maybe we'll just do 0.5. 0.1 is, again, the default, and I find it's just really slow. So 1 or 0.5 or something better, bigger. So, you know, you could start off right here. Well, okay, so this is the standard form. Can you move these sliders to match the blue graph, you know, and then what happens? So they just can play around and say, okay, well, what does A seem to do? Well, A flips it. So we know it has to be open. So I'm going to I'm going to leave it open. So they're exploring with that. So what have they just learned? They learned that this coefficient changes the open, up, down, positive, negative, that type of thing. And so then they could, okay, what's this? Oh, this one kind of moves it. So maybe I want to have it there. And then what's this one do? This one moves it up. Ooh, I'm close. So they could be playing around with this, but in the same time, they're learning about what each one of these coefficients is doing, right? So that's a great way to have students figure out what these coefficients represent and how it works with the parabola without you having to tell them anything. They're just exploring on their own, and then you could have them sharing their thoughts, especially if you're in this remote teaching environment. They could be playing around with this. You could send everyone this and have them come back, tell me what you think A does, and tell me what you think B does, those types of things. I could then use these same coefficients and do the vertex form. So I'm going to do the vertex form, and we're going to keep A, and then we're going to do X minus H. So I'm really adding in 2 more variables, right? Oops, I forgot to square. And so they've already kind of figured out, here's this same A. So this same A, notice what's happening. This same A will move both of them, right? So that's kind of cool. So in both forms, that A coefficient does the same thing. So that's a great connection that we don't often let students see, or it's very hard to see if they're doing it on paper and pencil. So, but now I can look at H and K and see what those do. And so maybe this might be where you look at the key features and see if you can make a connection. So H is 1, K is 1. Let's see if I move H to 3. What happened? Oh, my parabola moved. Let's look at the key points again. Oh, 3 and 1. Huh, that seems to match. So again, using the dynamic capabilities to help them discover on their own what these forms represent and what each of those coefficients and constants are doing. So any questions before I move on to that? Move on to the next one.
Nope, I think that's good.
Okay. Yeah, okay, I'm going to see. So this is a capital A, and I do think capitalization matters. I just wanted to show you one more way to think about doing this. I'm a huge proponent of really transformation starting from the parent function, because I think that really helps. So you could graph a parent function, and we're going to do, let's not do that. So the parent function of the absolute value. So let's do y equals absolute value of x. So there's the parent function. I don't want that to move, but now I'm going to use the standard form, and I'm hoping that because this is a lowercase a, that it will not be the same as the A up above, but I do want the same H and K because I did want to show you this is a really nice connection. So this, it creates new sliders down here, but notice this H and K are 3 and 1, so are this H and K, because the paper understands that anytime you use that variable, and even though this is a different graph, it's the same variable. Let's see. I want to see if my moving the A moves the A up above. It doesn't. Okay.
Right. So and another easy way to check too, you showed it earlier real quickly. If you go to the 3 dots in that upper right-hand corner.
Yeah, I'm going to go back to that in a minute. Yeah.
All right.
Thank you, Amy. Yeah, I'm getting there. But I did want to just show you that this is nice because we don't often connect, you know, the absolute value function to the quadratic function, this vertex form, and this whoops. I'm sorry, I'm going crazy with my zoom. The vertex form and the vertex form of the absolute value are really using that same idea of H and K, and we don't tend to connect them. But now look what happens if whoops, where's my sliders? If I move the H and K in either one of the sliders, it's going to move them in both. So I can actually see, wow, these are very connected types of equations. And if I understand what H and K mean in a quadratic, then I know what it means in my absolute value. So that's a really nice dynamic connection. And before I move on, I did want to Notice that I have lots of variables going on right now in my sliders. So my sliders are controlled by my variables that I created. And I can go up here to the three dots, as Amy was saying, and you'll see there's this thing called Variable Manager. And this just basically lists all the different variables that you have used. So I've used f of x is a function that I used in the calculate sticky. And these are then all, and I think there's a scroll down. So this will just tell me what they are. And if you decide, wow, I want to use this variable again somewhere else, but not have it be connected to these, you can actually, there's not much you can do right now. You can edit, and that just means you can delete them. So if I want to get rid of a variable that I'm using because I want to use it again somewhere else, I can hit delete and change them. We're going to leave them here for now. That's fine. Let's cancel that. So that's just a way to kind of list what, kind of figure out what you've already done so that you don't forget yourself, because everything is connected in ClassPad.net, so that's a nice feature. So the last thing I wanted to do in the graphing before we get into geometry and doing sliders in geometry is I wanted to talk about some ways you can use the variables to kind of control visualization. So I'm going to just type a function again. So let's, oh, purple, I like purple. So x to the third plus 3x squared. Ugh, I do that all the time. Arrow, you need to remember to hit the arrow. Plus 3x squared minus 1. All right, so you've entered your function. So those of you playing along, enter a function. I like this function because we're going to be talking about integrals, so it has a nice, integral that you can play with. And so I have my function. So whatever function you've entered, if you click on it, you get your key points that we already know. But if you go down here, the minute you click on a function in the graphing sticky, you get this extra button. So notice if I'm not clicked on the function, this button is not available to me. So it does connect to the actual function that you've clicked on. And when you click it, this is called the property button, you have, oops, I actually can't do that. There you go. You have three things that you could do. You could do the tangent to this curve. So it'll do a tangent at a specific point that you can then move. You could do the normal line, and you can do the integral. I'm going to just focus on the integral because that's one that you can do sliders, and I wanted to show you what you can do. So when you hit integral, it basically comes up with a template. And it's asking you, okay, where do you want to find the integral or the area under the curve between? So it's asking you for the lower and the upper bound. So I'm just going to put some numbers in right now. So let's say I just want to find out between, that looks like 3 and 1. So my lower is going to be -3. Whoops. So this is just a template that you're filling in based on where you want to look at the integral. So we're going to say -1. So I could enter numbers, and it's going to notice, whoops, let's move this guy out of the way. It's doing the integral between those two values, that lower bound and that upper bound that I gave it. And I could then go back in and change it and say, oh, that wasn't enough. Maybe it's 1.5. I'm sorry. Maybe it's -0.5. So that's a little bit more. That's a little bit better. So I could be playing around with it that way. But you can also use variables to make this dynamic where you can kind of move the integral and kind of explore different areas by using sliders. So to do that, we need to actually control it. If you think about it, what is the lower and upper bound? They're really x values, right? So I need to basically create variables to represent the x lower bound and the x upper bound. And I'm going to plot them as a function. And that's just a vertical line, basically. So I am going to do x equals, and we'll call, I like to try to match my variables to what I'm talking about. So let's call it L. So L is going to be my variable for my lower bound. So watch what happens. It graphs a vertical line at that lower bound, and default's always to land on 1, just so you know. And then let's do the same thing. Let's make a different one. And yeah, I guess we can do color. That's fine. And then we're going to use x equals a u for upper bound, right? So I'm trying to match this. But now I have sliders that control well, they don't control it yet because I haven't actually defined it. So these sliders are just, right now, just vertical lines, and they're both on ones. That's why they don't look different. So I can now move them, right? So that moves my vertical line as I would expect. But what I want to now do is change my integral. So my integral right now is using actual numbers. Instead, I want to use my sliders. So watch what happens. When I go back into the template, my lower bound I want to be L instead of a number. And my upper bound I want to be U, again, instead of a number. Now what happens, notice, and it might help if I change my lines so you can see them. I'm going to change, so watch what I did. I kind of want to make this visual stand out a little bit more. So when I click on the color of the function here, I have the option to make it a dashed line and to hide it. I don't want to hide it because it's basically controlling and visualizing, but I'm going to make them dashed so that it stands out a little bit more. So let's make them both dashed. But now what students can do is use the sliders to explore the upper and lower bounds and the areas. Notice that the areas are happening here. So that's just another way to use sliders to help you see and visualize the mathematics. So the area under the curve in this particular case. So any questions? We're going to move into geometry in just a second. Any questions?
Can you go back and show how you got the integral again?
Okay, so the integral is relatively easy if it's a function that has that capability. So all you do once you've graphed, you have to have a graphed function. You click on the function itself. So you'll know it's clicked because it gets all bold. And this little button down here in the left corner called property pops up, is available. And when you click it, here's the three things that you can do. So I just hit integral and it gave me this template. So basically it's a template. If you just want to see what these do, if I had hit tangent, it would give me, it picks an arbitrary point and gives me the tangent line at that point. But I can now move that point to wherever I want and it will show the tangent again and the equation of the tangent at that point. So that's the other thing that this does. And then let me just show you what the normal line does. Same thing, it gives you a normal line at a specific point. So if you kind of came to the same point here, you would see both the normal and the tangent line. Remember, they're perpendicular, so they can see that it's at the same point. So all of those happen when you click the function and choose this button in the left-hand corner called property. That answer that question?
Yes, thank you.
Okay. I am going to log into my account now because I am going into geometry, but I created something as a representation of what I mean. So in geometry, you can also use variables to control movement. And where it works in geometry is in the transformations. So rotations, translations, and dilations. You do not have the capability of doing a slider with a reflection because that doesn't make any sense. So just the three transformations where things are actually moving and turning and sliding, those types of things. So I just wanted to give you an example of something that was created using a slider. So, and this is just an example that I like to use a lot because it's a very common understanding. So this is a triangle with three different angles, and it can be any triangle, right? This is dynamic math. Okay, it should be able to be any triangle. Oh, I know what's going on. Hold on. Okay. It's a little slow because I put a rotation in there. There we go. So I can make it be any triangle. And so one of the most common things that geometry students learn, they learn this in elementary school, is that the sum of the three angles of a triangle are 180. Well, I created an activity where you are visually showing that that's true by creating the linear pair that these three create. And so I use rotation. So I basically selected the angles, rotated them around the midpoint, and I'll show you what I did after I show you the sliders. So basically you'll see I have two rotations. And if you look at the range, whenever you do a rotation with a slider, you have angles angles, so from 0 to 360. I only wanted to go to 180, so that's why it stops at 180. I changed the range. And notice I have one that's going from negative 180 to 0, and the other one's going from 0 to positive 180. And so the negative is how you change the direction of the rotation. So rotations are always, I believe, counterclockwise. That's the default. So if you want it to go clockwise, you have to make it a negative angle rotation. So I want to just show you what happens. So I already did this, and so this is going to rotate the angle, and it shows up afterwards just because of the way it works in geometry. But notice I am rotating that angle from down here and showing they're congruent because they're the same color, and you know, if we talked about this, these would actually be parallel lines. But now I'm going to do the same thing over here, showing them that I'm moving this angle. And by rotations, I now show you that these three angles, when they are set side by side, are actually all lying on a line, which means they must be 180, even if I change the triangle. And so now I could, it's going to be a little slow there, I could change the triangle and it still is true. So this is a visual proof, basically, using just properties and no measures. So that's a really nice way to use sliders in geometry to do these visual explorations. And I set this up ahead of time. And I'm going to show you real quick. I think I can do it. Okay, I'm clicking on somewhere, and I'm going to go to proper. No, that's, oh, I know where it is. Sorry. I wanted to show you all the things I hid. I hid all the things I didn't want you to see. I didn't want you to see my midpoints that I rotated around. So to get back things I hid, I can go into this visible thing and show all the things I hid. And you can see I hid all the measures and I hid my midpoints because I didn't want students to see that. You don't need measures. So that's just the background. And, all right, so I'm going to move down. And I want to just show you other ways, just how you use it in geometry. So geometry is just a little bit different. So geometry, I'm going to pull out a geometry sticky, those of you who have not worked with it. And I'm just going to, whoops, I obviously have something else here. I am going to, those of you who worked in the geometry sticky, you know that when you start drawing, it automatically labels. I tend to turn that off because I don't want the labels to get in the way of my discovery. So to do anything in any sticky, if you go to three dots, it's the settings. So here's all the things I can do. I can turn on grids. I'm going to turn off auto labeling. And so I'm going to hit OK. That's what I want. And now I'm just going to make a shape. And it doesn't really matter what shape I make. I'm just going to use my polygon tool and make a shape. And let's not make a triangle because I tend to use those often. We'll make a quadrilateral. So I want to just show you how easy it is to use sliders in geometry as well, and how it can really make students' discovery a lot more. Instead of just giving them the definitions and the properties, they can actually explore using the sliders and come up with those on their own. So the only things you can use sliders for in geometry are the transformations, which live under constructions, right? So here's all my transformations. So I can do sliders with rotations, translation by coordinates, and also a dilation. This translation by a vector is specifically a vector, so we're just going to use the coordinates here. So basically, your angle of rotation is where you're going to replace with a variable, and that creates a slider. Your translation coordinates are going to be replaced with, instead of specific coordinate points, you're going to do X, Y, A, B, however you want to think about it. And dilations are also a scale factor. So you're replacing the scale factor with a variable. So let me just quickly demonstrate. It's very easy. I want to select this shape, and let's just do a translation first. So I've selected it. You always have to select something before you're allowed to do anything. I'm going to go to construct, and here's my choices. And if I hit translation by coordinates, it's asking me, well, what coordinates? How do you want to slide it? So I could put in specific numbers. So let's just show you what that looks like. If I put in specific numbers, let's make it 2. It's going to translate. It's going to slide it vertically 3 and up 2, right? So that's what it's going to do. So if I hit execute, you're going to see a translation of this original by these coordinates. But if you do a slider instead, so instead, let's do, and again, I like to try to use representative variables, so H for horizontal and V for vertical. Now look what happens. And I also, when I use my slider, I'm not going to change, it will slide it, and I like to change my transformed figure into a different color when I'm working with students. That's always nice. But now I can explore. So what is this H, this X, what's it doing? It's moving it left, or, oops, I probably need to move my original over so you can see it a little. There we go. So now I can explore, what do I think, what are these coordinates doing? What is that X, and notice, what is the X coordinate doing? What is the Y? And notice that it's using the true values up here as well. So you see the values in the slider, and you see them on the screen of the object. So now they can really try to make that connection. What does this coordinate? And if you want, you could add in the axes, you know, if you're working with coordinates. So very easy to use and create sliders in the geometry. You're just replacing the numbers that it's asking for with a variable. So let me just show you now. I'm going to do the same thing. I just want to show you each one quickly. I'm totally going to run out of time doing the things I really wanted to get to, but let me just do another. We'll do a triangle. We'll be boring this time. So here's a triangle, and let's say now I'm going to select it. So you always, again, have to select. You're going to go to your construct menu, and this time let's do a rotation, a turn. And so for a rotation, the first thing you have to have is a point. It needs to know, where do you want to turn around? So since I didn't put an extra point somewhere here, I could just choose a point in my shape. So I actually am going to put a point, because I like to have a point of rotation. So let's try that again. Construct, rotate, select the point you want to turn around. And here again, I could put in a specific angle. It's asking me for an angle. So I could say, let's say 90, rotate that 90. And notice it is rotating counterclockwise. That is the default of the angles on here, is to go clockwise. And if you wanted to go, no, did I say counterclockwise? Counterclockwise. And if you want to go clockwise, you have to do negative angles. I'm just going to change the color real quick. So if I go back to this, and instead of a number, so I could put in any angles, negative 360 to 360, and it will actually go before. It'll just turn more than 360, right? If you did 400, it's going to go 360 plus. But I'm going to put in A for angle. So now I have a slider that controls the rotation, and this is really nice. Now notice, I don't know why it does this. It doesn't start at 0, but you could do negative 360 to positive 360. And now you can talk about, all right, well, when is the rotated image exactly the same as the original? Well, when you have no angle of rotation, right? So they can explore, what do rotations do? Well, that turns it. They could, you know, put in segments and see that the angle of rotation is between the corresponding points, those types of things. But they can explore, because now you have a slider, and they can really kind of look at things and figure them out on their own. And lastly, same thing, and actually, you know what? Let's just use the same shape. I'm going to get rid of my rotation. Notice I got rid of everything. And now I'm just going to use the same shape, and I'm going to do a dilation. A dilation also requires a point, meaning a point to dilate towards or away from. So I'm going to use the same point. So I'm going to go up here, construct, choose dilation this time. And again, notice first thing is select the point. So I'm going to point. There's my point of dilation. And now it's asking me for my scale factor. Do I want to be larger, smaller than 1? So let's just do a 0.5. And so notice that it creates a dilated image of the original 0.5 half towards the point of dilation. And I can, you know, move the point of dilation if that is something that I want to do. But here's where, again, instead of a number, you can use a variable. So let's just use the letter D for dilation. And now look what happens when I get, oops, you're not seeing this because I'm making it really big. There's my dilation when it's larger than 1. What happens when I'm smaller than 1? I get really small. What happens when, I love this, what happens when your dilation is a negative? It actually flips it, right? So it's a lot of different interesting things you can do when you're using, or you could limit it and not go past negative if you're, depending on your students. So that's how you use it in geometry. It's the dilation, the translation by coordinates, and the rotation. Any questions?
Nope, no questions.
All right, I'm going to start a new paper because I really wanted to show you how you can have a lot of fun with the sliders and movement and really kind of, and functions, and create some fun images, because you can also use variables to control images. And I'm trying to get a new paper here. It doesn't seem to want to go. Oh, there we go. A little slow. So in the whatever time I have left, and I'll go over if I want, I'm going to take the graph out. I'm going to pull up a graph, and I'm going to try to show you how you can really work with students to be creative, make an art object, and use sliders to move images. Because if you notice, those of you who've not played with ClassPad, we were entering functions, but you can also enter images, and we can use images with sliders to control the movement of those images. So I'm just going to do an example of a very simple image of I'm at the ocean right now, so I keep thinking of fish and sharks. So that's what I'm going to do. So I'm going to create, first I want to have the ocean. So I want to use some shading. So that's an inequality. So, and I want it to look wavy, so maybe I use a sine curve. So I'm going to create, oops, I want an inequality. And I want it to be less than. So here's my templates. So my less than or equal to are here, or if you're on your computer, you can do the less than symbol and the equal, and it will make it 2. But there's less than that, and I want sine. Whoops. Actually, I'm just going to use the template here. That makes it of x. There we go. So watch what happened. Because I used less than or equal to, it's shaded in. So now I got my ocean. And eventually I'm going to probably hide my grid, which I know I can do because I can go into my settings and turn the grids off and on, but I'm going to leave it there for right now. So now I want to put a fish in, and I want the fish to look like he's swimming. So I want a function that controls the fish. So I can define my function in the calculate. So I think I'm going to do that. Remember, this is what we did before. So I'm just going to get my calculate sticky out and define an f of x to be cosine of 0.5x minus 3. So I'm in the calculate sticky, so when I hit it, it's just going to say, okay. No, what did I do wrong? Oh, I didn't use cosine. Sorry, I needed to actually use it. Sometimes it doesn't interpret it. It interpreted that as a what? Okay, Amy, what am I doing wrong?
You didn't use the colon.
Oh, thank you. I didn't define it, so it's actually trying to find a solution. It's confused. So I went back to, okay, so now it's defined. Yay. So now that's defined, and I'm just going to kind of put that under my graph because I don't really need it anymore. Because now what I'm going to do is I'm going to graph that function just for the moment. So I want y equal my f of x. And so this now is going to be the path I want my fish to be moving on. So I want to see it now until I get my fish on there. So now I'm going to actually enter an image onto this. And before I do that, I want you to remember what we did with the integral. So remember we used x equals a to kind of control an x value. I'm going to do the same thing here. I'm going to define an x equals a. And all that's going to do is give me a vertical, but now I have a variable that will move with the green line. And actually, I think I'm going to make my step 1. So it's going to move, right? It's controlling my x values, right? So now I'm going to enter my image, and I'm going to show you how I'm going to use these two things to help me actually attach my image to my function at that specific value of a. So when I enter my image, I'm going to click my image, and I'm going to go to my fish. So here's my fish. I'm going to open my fish, and when I hit OK, it puts my fish automatically centered at 0, 0. and it's also a very large fish. So I want my fish to be smaller. So here's a template that now once you have your image in, you can play with. So I'm going to make my fish smaller. Let's divide by 5. So that's a 2 and a 2.08. So now my fish is smaller, awesome, but he's not in the right place. I want him to be controlled by the A. So I want my X to be A. So all I'm doing is replacing this with my slider value, which is A. So now watch what happens if I move my slider. My fish will basically, whoops, move with the slider. He's controlled by that slider. And then I want it to be on this function, right? So I really want it to be at f of A. So I'm going to actually enter that in here, f at A. And now my fish, when I move A, is moving on the function. He's staying on the function. I could even, he's kind of pointing up. He's a very happy fish. So I could even change my angle. So I want my angle to go clockwise. So remember, that's a negative direction in this particular case. So now I think maybe a little bit more. So I'm just playing around. Kids can play around. So let's make him 35. There, he's a little bit better. And so now I have this fish being controlled by this slider and moving along this function because of how I interpret or put them into the template basically once after. And maybe I want to change my range here. I don't want my fish to go past -7. I'm just going to change my fish range, and I'm going to change this to, let's make it +7. And so now if I hit animate, you can see my fish is moving nicely along and he's kind of going to repeat himself. And now I don't need these two anymore, right? I don't need I don't need this function graph, and I don't need this function graph. So this is where hiding comes into play, even though you can still see the function, but you don't see the graph of the function. You just see the fish moving. So now let's try that again with my fish. So there's my fish moving along. And notice he is hiding behind the axes. I'm going to turn those off, or I can move him to the front so that he's in front of the, except I have to stop the animation. All right. So now the next thing might be, okay, maybe I want a shark chasing him. So and what's my time? Amy, stop me if I need to stop.
We have about 6 more minutes.
Okay, and I'm going to define another function. I could actually enter the function, but I'm going to define another function to just be, colon equals, let's remember, to just be a straight line. I'm going to have the shark swim in on a straight line. Okay, so I'm going to graph that function, and it doesn't matter what color it is because I'm going to eventually hide it. So y equals g of x. So it's just going to be a line there, right? And I want another x control. I don't want the same x control because then they're moving the same. So I want just another x equals b this time. So notice now I have 2 sliders. One controls my fish and one's going to control my shark. B is going to control my shark. So let's make the shark go a little slower. They're stealthy. And so I'm going to do the same process. I'm going to get my picture first. So I'm going to add another picture, and I'm going to get my shark. He's going to be big when he comes in. Hit OK. So you have to have it entered first. So he's very large right now. He's really going to hurt that fish. But now I can change the size. I can play around with the size. And so let's just make him maybe 4 and 4. Whoops. And again, I want to use this function g at this x value b. So g of b is what I really want. So I want the x control to be b. That's controlling where he is on x. And then I want my function to be g at b. And so now you'll see my shark is being controlled by b. And maybe we want them both to start at -7. And it's okay that my fish is in front. And now I can just animate. and let's see what happens. We'll start the fish first. And now my shark's trying to get the fish. So lots of fun that you can play around with, and then I would hide these functions. So that's just another, it's just a really fun way. What function is going to create different things. I've tried some for Halloween where I have witches flying on a broom, but it's really using functions and really kind of understanding the input and the variables that you need to help control things. So that's all I was showing you today, is all these different ways you can work with sliders and functions and kind of have some fun and really help students use discovery versus giving them, you know, definitions and formulas. Any questions?
No, no questions. Just
Okay,
let's make sure we save the fish.
Yeah, I'm gonna save the fish. I have tried, by the way, just those of you who are interested in using images, you know how sometimes images, they say they're transparent. They don't show up transparent on ClassPad for some reason. So I do have to, you know, ask them, can we make that? And I want to show you what happens if I hide all my numbers, then you just see my little fish swimming along. So thank you very much for joining me tonight, and Amy, and thank you, Amy, for moderating the chat. And if you have any questions, let us know. And so, Amy, you can take over if you want. I should probably put the shark in front. Amy, are you going to pull the slide up?
Yes.
Oh, now the fish is chasing the shark.
We'll see. I was letting it play out a little bit.
So that might just be playing around with, you know, well, what do you want the steps to be? Do you want the shark to go really slow? That kind of thing. So that's a fun kind of way for students to be thinking about how they use these controls and slides and functions.
Yeah, absolutely. All right, so as Karen said, thank you guys for joining us tonight. We are continuing the conversation with looking at calculus in ClassPad.net, so diving a little bit deeper into some of the things that Karen showed on November 5th. But we also have 2 other webinars coming up, October 15th and November 19th, on featuring our hardware calculators. So the 9750 G3 on the 15th of October, and we're going to be looking at a few of our different models on November 19th. So if you're interested in joining us, please check out the websites there to sign up for those webinars. We will be taking a break after November 19th through the holidays, and we haven't figured out when we're going to start back up on these types of webinars. We're thinking maybe February, so just keep a lookout for that.
And let us know if you have a request and you want to see something.
Absolutely. And then we are wrapping up our last month of our Equity in Education webinar series. I know that some of you guys have been joining us for those. So this is the last month of that. We do have 4 starting in next week. So basically 1 a week. So take a look at those. We just got the information for October 20th, so that will be up on our website shortly. But if you go to Casio Education webinars, you will be able to find those there as well. And last but not least, thank you for joining us. Be sure to follow us on social media. That's where we will be posting any of our webinar information, as well as when we start back up in the spring.
Yep. So thank you, everyone. And if you have questions, just email classpadnet@gmail.com, and Amy and I are the ones who get that, so we will answer them.
Yes.
All right. Have a good night.